In the year 2036, something will happen that most people alive today will never read about in a headline. There will be no breaking news alert, no congressional hearing, no viral moment on social media. Deep inside Voyager 1, the plutonium cores powering its radioisotope thermoelectric generators, its RTGs, will finally decay past the point of no return. The power output will drop below the threshold required to keep the heaters running. One by one, the systems that have kept the spacecraft functional across 5 decades of brutal cold and radiation will shut down. A graph drawn by engineers at NASA's Jet Propulsion Laboratory shows a line. That line has been falling for years. When it crosses the bottom of the chart, it means the conversation is over. Not metaphorically, literally over. The spacecraft will begin to drift, silently, slowly rotating in the dark, with no one to correct its course. The cursor on the empty monitor will keep blinking. No one will be typing a response. But to understand why that moment matters, why it carries a weight that is almost impossible to articulate, you have to go back. You have to go back to a warm September morning in 1977, to a launch pad in Florida, to a crowd of scientists and engineers wearing bell-bottoms and thick-rimmed glasses, their faces tilted up toward a sky that was about to change the history of our species. The Titan IIIE rocket left the ground with a sound like the world tearing open. It climbed through the clouds and left a trail of fire above the Atlantic coast. Inside its payload was a 1,590-pound spacecraft, compact, elegant, bristling with instruments, aimed at the outer solar system using a planetary alignment that only comes around every 176 years. They called it the Grand Tour. They got it exactly right. The trajectory was mapped in advance with extraordinary precision. Voyager 1 would use the gravitational pull of each planet it encountered as a kind of cosmic slingshot, accelerating without burning a single additional drop of fuel. It was genius disguised as physics. The solar system itself became the engine, and the spacecraft rode it like a surfer reading a wave that no one else had ever seen. Jupiter came first. When Voyager 1 arrived, it sent back images that stunned every scientist who looked at them. The Great Red Spot, a storm larger than Earth itself, raging continuously for centuries, appeared in detail so sharp it looked almost painted. The moons of Jupiter swept past the camera in a kind of silent parade. Io, with its active volcanoes, Europa, with its cracked icy shell hiding an ocean beneath, Ganymede and Callisto, ancient and pockmarked and magnificent. No one had ever seen them like this. No one had ever seen anything like this. Then came Saturn. The rings, which had always looked like a simple flat disk from Earth-based telescopes, revealed themselves as something infinitely more complex. Thousands of individual ringlets, each one composed of countless particles of ice and rock, some the size of a grain of sand, some the size of a house, all orbiting together in a structure of breathtaking precision. Voyager 1's cameras captured the detail of each icy fragment as the spacecraft swept past at nearly 40,000 miles per hour. It was, by any measure, one of the most beautiful things the human race had ever seen. And then came the moment that changed everything. It was February 14th, 1990. Voyager 1 was already 3.7 billion miles from the Sun. At the request of the astronomer Carl Sagan, the mission controllers commanded the spacecraft to turn its camera back toward the inner solar system for one final portrait. The resulting image showed Earth, our home, the only world we have ever known, the place where every human being who ever lived was born and died and loved and suffered, as a pale blue dot. A mote of dust suspended in a sunbeam, barely visible, barely there. Sagan looked at that image and wrote words that have not lost a single atom of their power in the decades since. He wrote about the rivers of blood spilled by conquerors and kings, all those triumphs and tragedies, happening on a speck of dust floating in the cosmic dark. He was right. He was more right than even he probably wanted to be. That image is still the most humbling photograph ever taken. After Saturn, Voyager 1 was no longer following the ecliptic plane of the solar system. It was climbing upward, away from the disk of planets, on a trajectory that would eventually carry it out of the solar system entirely. For years, the spacecraft continued to send data, measurements of solar wind, magnetic fields, the density of charged particles, as it made its way toward the edge of the sun's influence. That boundary, known as the Heliopause, is where the solar wind finally loses its battle against the interstellar medium. It is where the sun's reach ends and interstellar space begins. In 2012, Voyager 1 crossed that boundary. It became the first human-made object in interstellar space. The onboard magnetometer noticed the change immediately. The compass needle, metaphorically speaking, began to twitch. The environment was different. The pressure was different. Everything was different. Voyager 1 had left the sun's neighborhood and entered the open ocean of the Milky Way. A compass built for one world suddenly found itself in a place where none of the old rules applied. Engineers at JPL watched the data come in with a kind of quiet disbelief. They had spent their careers working toward this moment. Some of them had been on the project since before some of their colleagues were born. The signal took 19 hours to arrive. Standing in mission control, looking at those numbers, a person could be forgiven for feeling something close to vertigo. Because what the numbers were describing was not just a machine crossing a line in space, it was a threshold, a first, something that in the entire history of this planet, 4.5 billion years of geology and biology and eventually thought, had never happened before. Something built here had made it there, out, beyond, into the actual stars. The golden record was always part of Voyager's story, even from the beginning. A 12-inch gold-plated copper disc, designed by a committee chaired by Carl Sagan, loaded with sounds and images and greetings representing the full breadth of human experience. The sounds of surf and wind and thunder, the calls of whales and the songs of birds, a mother's first words to her newborn child, music, Bach and Beethoven and Chuck Berry, and a Navajo night chant and a Peruvian wedding song, spoken greetings in 55 languages, including a simple English message from the then President of the United States, mathematical diagrams, the location of Earth relative to 14 pulsars, those spinning stellar lighthouses whose precise timing could serve as a cosmic address, and a diagram of the human form, a man and a woman, depicted neutrally and openly, reaching outward. The cover of the record includes a diagram showing how to play it. Scientists called it a message in a bottle, cast into an ocean so vast that the bottle may drift for billions of years before it ever reaches a shore, if it ever does. Close up, the golden record reflects the distant stars like a mirror. Whatever it has seen on its journey, it has carried the image of that September morning in 1977 inside it, encoded in the grooves. The hand of the engineer who sealed the spacecraft hatch before launch pressed down gently, checking the seal one final time. That gesture, practical, careful, human, was the last physical contact between our world and the machine that would outlast everything we have ever built. By the year 3000, Voyager 1 will enter the Oort cloud, the vast spherical shell of icy bodies that surrounds the solar system at an enormous distance. Millions of comets drift there in frozen silence, barely held by the sun's gravity, barely moving. The spacecraft will pass through this region for tens of thousands of years. Occasionally, a micrometeorite will strike the hull, a tiny spark in the darkness, a brief flash of light that no one will ever see. The sun, by this point, will look like just another star, slightly brighter perhaps, but not much, and Voyager 1 will pass an iceberg the size of a mountain and continue on, indifferent and unstoppable. 30,000 years from now, the spacecraft will still be crossing the Oort cloud. Every trace of human civilization on Earth will be long gone, not destroyed necessarily, but buried under the accumulated weight of geological time. Languages we speak today will be as lost as linear A. The architecture of our cities will be as invisible as the villages of Homo erectus, and yet the spacecraft will still be moving at roughly the same speed it has always moved, 38,000 miles per hour, quiet, alone, carrying everything we were inside a golden disk. In approximately 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445, a red dwarf in the constellation Camelopardalis. Not a close pass, it will still be an enormous distance away, but in cosmic terms, it is a near miss. If there is a planet in the habitable zone of that system, and there may be, the spacecraft will drift past it. It will pass by without transmitting, without announcing itself, without anyone on board to wave. Whatever life might be looking up at the sky from that distant shore will not notice. The spacecraft will continue on. The outer antennas, by this point, will have been slowly eaten by radiation. The metal hull will be darkened and pitted. But the golden record, protected by its aluminum jacket, will remain untouched. The information inside it, the sounds of Earth, the images of humanity, the location of our star, will still be intact. A message that may never be read, a letter that may never arrive, and yet it was written with the full force of human hope and human longing and human daring. That counts for something. Maybe it counts for everything. 1,000,000 years from now, the continents of Earth will have shifted into configurations no geologist alive today could predict. The Himalayas may be gone. New mountain ranges may have risen from the collision of tectonic plates we have not yet named. There may be no record anywhere on Earth's surface that human beings ever existed. But Voyager 1 will still be moving, still carrying its cargo of human sound and light and mathematics. We will have vanished. It will remain. The spacecraft will pass through the remnants of supernovae, those enormous stellar explosions that scatter the elements of life across the galaxy. The clouds of gas and dust, glowing in a dozen colors, will backlight the hull of the spacecraft like a stage. The golden record will catch that light and gleam. It is an image almost too beautiful to hold in the mind. A human artifact, adrift in the aftermath of a dead star, shining. When Voyager 1 eventually completes its first orbit around the center of the Milky Way, a journey that takes approximately 225 million years, what astronomers call a galactic year, it will have survived things we cannot fully imagine. Gravitational tugs from binary star systems, passes through nebulae so dense with young stars that the surrounding space glows. It will have drifted through regions of the galaxy where the star density is 100 times greater than our quiet suburban neighborhood of the Milky Way. The hull will be dark by then, almost featureless from erosion. The spacecraft will be, in some sense, a ghost. A ghost of engineering, of ambition, of a species that once looked up at the night sky and decided that looking was not enough. 1 billion years from now, the sun will have swollen into a red giant. It will have expanded until its outer atmosphere engulfs the inner planets. Mercury and Venus will be gone. Earth, our pale blue dot, our only home, will evaporate in the fires of its own star. Everything that was ever built here, every book ever written, every song ever sung, every name ever spoken, will cease to exist. There will be no physical record of our civilization anywhere in the solar system. The sun itself will eventually cool and shrink into a white dwarf, a tiny ember glowing faintly for billions of years. But Voyager 1 will still be out there, moving, carrying its record, the only proof in the entire universe that humanity ever existed, the only trace. In deep intergalactic space, trillions of years from now, the era of star formation will have ended. One by one, the galaxies will have exhausted their supplies of gas and dust, and the great stellar nurseries will have gone dark. The universe will be entering what cosmologists call the degenerate era, a long, slow twilight in which the only stars still burning are the smallest and most efficient red dwarfs, grinding through their fuel at a masterly pace over timescales that dwarf the current age of the universe. The Milky Way and Andromeda will have long since merged, their collision producing a burst of new star formation before settling into a new, larger elliptical galaxy. In the chaos of that collision, Voyager 1 will survive, passing through the vast empty spaces between stars, untouched by the violence of merging galactic cores. Eventually, far beyond any number that can be spoken aloud with meaning, the last stars will go dark. The universe will be black. Only black holes will remain, slowly evaporating over timescales so enormous they make the current age of the cosmos look like a single breath. In that absolute darkness, Voyager 1, or what remains of it, will be the last complex object in existence. The metal atoms of its hull will begin to decay. The spacecraft will dissolve, slowly, into a cloud of elementary particles. The process will take longer than the entire history of the universe has taken so far, multiplied by numbers with so many zeros they have no name. The golden record will be the last piece to go, and when it does, the information it carries, every sound, every image, every mathematical diagram representing the full breadth of human experience, will disappear forever. There will be no physical record, anywhere in the universe, that human beings ever existed, that Earth ever existed, that anyone ever looked up at the night sky and felt the particular mixture of wonder and terror that comes from truly understanding how small we are. But here is the thing. Here is the thing that matters. All of that was always true. Before Voyager, before the space program, before the first human being ever scratched a mark into a cave wall or ground two stones together to make fire, the universe was already vast and cold and indifferent. The darkness was already there. The emptiness was already there. And still, against all of it, against every physical law that should have made curiosity an evolutionary accident, a species on a small rocky planet in an unremarkable galaxy decided to build a machine and throw it at the stars, not because it was practical, not because it was profitable, because it was true to something deep inside us, something that cannot be reduced to survival or reproduction or economics, something that simply looks outward and says, I want to know. Right now, today, in 2026, the engineers and scientists at JPL and the Deep Space Network facilities around the world are still listening. The signal from Voyager 1 takes more than 23 hours to travel one way. By the time a command is sent and a response received, nearly 2 days have passed. The data rate is measured in bits per second, slower than the slowest dial-up modem from 30 years ago. And yet, there are people who devote their professional lives to this conversation, who come in every day, read the numbers, and translate them into understanding, who are, in a very real sense, the last people on Earth to hear from the farthest thing that humanity has ever touched. The antenna of the Deep Space Network tilts upward toward a precise point in the sky. It listens. The radio waves arrive, stretched thin by distance, faint as a whisper in an empty house, and are received. For now. There will come a day, likely around 2036, possibly sooner, when the last usable signal from Voyager 1 will arrive. Engineers will note it. Some of them will feel it in the chest, that specific ache that comes from the end of something that mattered. The screens will go quiet. The cursor will blink, and Voyager 1 will continue on its way, as it always has, into the dark. A child somewhere tonight is looking through a telescope. The image is blurry, the mount is wobbly, the eyepiece fogs up with breath, but the child is looking. At Saturn, maybe. At Jupiter. At a star that might have planets. At a sky full of questions. That child is the reason Voyager was built. That child is the reason it mattered. That curiosity, raw, unpolished, ungoverned by any sense of practicality, is the most human thing there is. We sent a machine to the stars not because we knew what it would find, but because not sending it was unthinkable. We put our music and our voices and our faces on a golden disc and bolted it to the side of the spacecraft, not because we expected anyone to find it, but because leaving without leaving something felt wrong. We aimed the antenna and listened for decades, not because we were confident the news would be good, but because the alternative, silence, chosen silence, silence by default, was never really an option for a species like ours. Voyager 1 is still out there, moving through interstellar space at this very moment, crossing a distance it would take light itself years to cover, carrying everything we were and everything we hope to be. It is not coming back. It was never coming back. That was always the point. We sent it because we had to, because we are the kind of creature that looks into the dark and reaches, even knowing the dark does not end, even knowing we will never see what our hands are reaching for, even knowing that one day the signal will stop and the machine will drift and the stars will go out and even the memory of memory will be erased. We reached anyway. That is what Voyager 1 is. Not a machine, not a mission, a gesture. The most expensive, most precise, most enduring gesture in human history. A way of saying, to a universe that may never read it, we were here. We were curious. We were brave enough to be small. Subscribe to Dark Orbit and keep looking up.